Today I want to continue talking about solving quadratics. I first want to review what does it mean to solve a quadratic. And remember, to solve a quadratic means to find the x-intercepts. Okay? And the x-intercepts are where the graph crosses the x-axis. Remember that y equals 0 when you're crossing the x-axis. These are also called the zeros of the function. And if you think about it, the y value is 0, so these are called the zeros of the function. They're sometimes referred to as the roots, or we would often say we're finding the solutions. Now, keeping that in mind, now I'm going to give you a couple equations that we're going to solve. And our method that we're going to focus on is factoring. So we want our equation, remember, to be in standard form. So in other words, we want our equation to be set equal to 0. Once we do that, if we identify our a values, our b value, and our c value, now we're ready to plug that into our x method. And remember, this is just a method in order to actually organize your work. We multiply our a times c, and we get negative 14, and we bring our b value down. Next step is that you actually write the factors of this 14. Once you have the factors listed, you're going to ask yourself which pair of factors, when added or subtracted, will actually give you this 5. And we can see that it would be 2 and 7. And then you have to ask yourself, how do you get 5? Do you add these two numbers together or subtract? Well, we would subtract 7 minus 2 to get 5. If they're subtracted, then that means we must have one positive and one negative value. Since this is positive, that goes to the larger of the two factors, and then this one has to be the opposite. Now what we're going to do is we're going to take these numbers and we're going to plug them back in, and what we're going to do is just actually rewrite that term. Okay. Once you do that, you're going to group the first two and the last two terms, and then you're going to factor out something, and we factor out an x. Out of the next two, we factor out a 7. And then we can see between these two terms, meaning they're separated by that addition sign, what do they have in common? And we see that they have x minus 2 in common. We're going to divide that out. And you can see now we're left with x and a positive 7, and we bring those together. So these are the factors of this equation. Now what we're going to do is we're going to separate our factors and set each one equal to 0. We're going to add 2 to each side. So we get 2 as one of the solutions, and we're going to subtract 7, and we get negative 7. So these are the solutions. These are where they cross the x-axis. The coordinates, keeping in mind, are 2, 0, and negative 7, 0. All right, so that's one equation. Let's look at another just to practice. All right, so we have again our equation. It is written already in standard form with our highest exponent being 2, and it is set equal to 0. So we identify our a, our b, and our c value. Again, make your giant X. Remember, you're going to multiply your a times your c, and you're going to get 12 and 7. Writing down your factors of 12, remember your top number. And once you have the pairs of factors listed, you ask yourself which pair would actually, when added or subtracted, give you 7. You see that it's 3 and 4. 3 and 4 must be added together to give you 7. So that means if they're added, that they must have the same sign. They must be both positive or both negative. And you can decide, because since that is positive, then that means each of these have to be positive as well. So we have x squared plus 3x plus 4x plus 12. All right, now what we're going to do is we're going to divide out a common factor. And And then once you have them separated, you look and see that they have the x plus 3 in common. So once I divide that out of each of the terms, you see then I cross that out and I can see that I'm left with x plus 4. Okay. Now we're going to set each factor equal to 0. And then you're going to solve. Once you see that these are the solutions, these are where they actually cross the x-axis, the value of x when they cross the x-axis. So you can see that our roots are -3, 0 and -4, 0. And I'm hoping that you're able to make the connection here. Do you see that 3 and 4? And you see how our actual factors are x plus 3 and x plus 4. Some of you may recall that from our last unit before we went on break. And then my very last example is one like this, just to keep that in mind. We look at this equation, and I hope that you notice that it's not in standard form. It's not set equal to 0. So we are looking at taking this value, and we're going to bring it to the other side. So now we're ready to factor. So we make our giant X, and again, you can identify your values, taking your A and your C, and you multiply them together. And then you take your B value and put it on the bottom. So we have 1 and 15, and 3 and 5 are the factors of 15. And you ask yourself which of those factors would give you a 2. So you can see it's 3 and 5. We would be subtracting them, which means that one of them have to be positive and one of them have to be negative. Since this value is positive, that goes to the larger of the two factors, and then the other one gets the opposite sign. We plug these back in to the original equation, and now what we're going to do is group the first two, group the last two, and then factor something from each pair. So we take an x out of the first, and we take a positive 5 out of the second pair. And we want something in the parentheses to be the same, so we know we're on the right track. So we're going to divide that out, and when you do, you're left with x plus 5. Okay, now we're going to separate. And then solve. So you can see that the signs would change. I'm kind of running out of room on the bottom there. And then that would be our solutions. Okay. One last one. Let's see that if you can do that on your own. So you rewrite the problem, and then I want you to identify your A, B, and C values, plug them into your giant X, and see if you can find what the roots are. So here are my solutions, and remember, if I wrote them as coordinates, I would write it as that. Okay?